Hello, my dear student. I'm Saktwala from Educators. I'll be with you in physics for Form 5. Now, welcome again for our subtopic of rotation of rigid bodies, for our subtopic of moment of inertia. That is what we are going to discuss for our today session. So, before we proceed here, we were supposed to remember where we ended on the last session. On the last session, my dear student, we tried to see the moment of inertia for the cylinder, and we say that this moment of inertia for the cylinder is divided into two parts. That we should know the formula of the moment of inertia for the solid cylinder, and also we should know the moment of inertia for the hollow cylinder. Now, on the last session, we tried to complete. We completed on the solid sphere, on the solid cylinder, and we say that the moment of inertia for a solid sphere must be equals to half mr square. And we concluded by saying that always this formula is related with the moment of inertia for the disk. So the disk and also the solid cylinder must have the same formula of obtaining the moment of inertia. That is what we tried to see on the last session. So on our today's session here, we are going to see the moment of inertia of the hollow cylinder rotating about an axis through the center. That is what we are going to see. So we try to see that this is divided into two types, and we completed on the first one. Now let us see that if we have the hollow sphere, such as the hose pipe, now it is trying to rotate about an axis through the center. Now how can we get the moment of inertia? That is what we are going to see on our today session. So consider our figure here. Now we are going to see our figure number 11 for our fourth topic. On our figure number 11 for our fourth topic, we are going to see the mass. We are going to see the hollow cylinder, and that hollow cylinder containing the mass m and also the radius r that is trying to rotate on an axis. That is trying to rotate on an axis perpendicular to the axis of rotation. That is what we are going to see. The axis of rotation is labeled as the PQ, as we try to observe. So it is passing through its center. So this hollow cylinder passing through the center. It is rotated perpendicular, trying to rotate perpendicular to the axis of rotation and give us the moment of inertia. So how can we derive the moment of inertia for the hollow sphere? That is what we are going to observe for our figure number 11 for our fourth topic here. So as we observe that, let the cylinder be divided into the small ring. Now imagine we have the hollow cylinder, and that hollow cylinder is divided into small ring. It means inside the hollow cylinder we have the small ring. Now even those small ring contain their masses. It means that the first ring that are found inside the cylinder must have the mass which is equal to m1, and also the second ring, a small ring that are found inside the hollow cylinder must have the mass m1, and also dash until to the center ring. If we have several rings, we should expect it as the end stems of the ring. Now each of those rings must have the same radius, must have the same distance from the axis of rotation. Because the ring ambazo, small ring ambazo na found inside the hollow cylinder must contain, my dear student, it must contain the radius r, as we try to observe here. So after this one, what we are going to see, the thing that we are going to see here is that imagine we have our figure number 11 for our fourth topic, and this figure having the mass, it containing the masses which having the mass m, and also it contains the small ring, as we try to see that it have the ring, as we try inside we have the ring, and also we have the axis of rotation which is called the PQ. We have the radius from the axis of rotation up to the ends, as we try to see on our cylinder. And this cylinder tried to rotate perpendicular to the axis of rotation, as we observe, my lovely student here. So our figure here represent the hollow circular cylinder with rotation at its center. Now it's trying to rotate on its center, as we try to see here. So how can we demonstrate the moment of inertia related with what we observe here for the hollow cylinder that contain the small ring that are found inside? So from equation number 4.24, now let us reflect for our equation number 24 for our first topic. The moment of inertia of a small ring of mass mi, as we tried to see that if we remember for the slide that for the past slide, or for the past session, we say that the moment of inertia of consider the moment of inertia of a small ring. Now that moment of inertia containing the small ring, it containing the small rings of mass I. Mass I expect all stands for 1. It means I should be 1, should be 1, should be 2, should be 3, up to the n stems if we have more or many small rings. Now this is located at the distance r from the center of the ring is given by this one. So how can we get the moment of inertia for the small ring that are found inside the hollow cylinder? Now we could say that the moment of inertia for the small ring must be equals to mi times r square. Kwa hiyo hapo tunaipata ni sawa na mi times r square. This should be the moment of inertia, my lovely students here. So I must be equals to mi times r square, where I represent the moment of inertia for many rings, where mi represent that those small rings contain their masses. It means their masses should vary. We should have the mass 1, mass 2, mass 3, and so on. But the radius is still being the same. They are being the same, the radius from the axis of the rotation. So after this one, my dear student, what we are going to do after this one? Now after this one, we could say that the total moment of inertia of the hollow cylinder about an axis PQ through its center is the sum of the moment of inertia of the small ring for the whole solid cylinder. So ile moment of inertia sasa ya ile hollow cylinder about an axis, kwenye axis of rotation, itakuwa ni sawa na ile sum of the moment of inertia of the small ring for the whole solid cylinder. This is how we are going to demonstrate, and we could say that I must be equals to m1 r square if we add by m2 r square if we add by m3 r square, r power 2, as we try to demonstrate. This should be the r power 2 or r square. Times we add by dash n stems of mn r square. Now my dear student, here is that the moment, the total moment of inertia for the hollow cylinder must be equals to the sum of the moment of inertia for the small ring. Kwa ile moment of inertia ya ile hollow cylinder about the axis of rotation through the center itakuwa ni sawa na ile summation, the summation of the moment of inertia the moment of inertia through the small rings for the whole one. Kwa hiyo itakuwa ni hivyo, ndio maana tumezisum pale, tumezi contain. This is how we can expect the moment of inertia. So by saying this, this should be our equation number 45 for our first topic. Lakini hizi label za equations zisikufanye utoke kwenye mstari. you have to know unataka ujue kabisa kwamba the total moment of inertia of the hollow cylinder through the axis of rotation kwenye center must be equals to the sum of the moment of inertia for the small ring of the whole cylinder. So after this one, my dear student, now we are supposed to recall our equation number 4.45, which can be written as this one.